Right, we're going to look at example 13. This time we've got translations. So this one is a translation. It's not within the x, so it is in the y direction. And it is a translation, remember we write it as a vector of 0, -1. So it is exactly what it is there. So that is basically the sine graph that has moved down 1. So if we think about what the sine graph looks like, it would originally go up here to 1 and come down. It's going to start at 1, go up, and come down, and end there at -1. So y-axis, x-axis. That would be 360. So if that's come down 1, this has obviously come down to -2, 90, 180 and 270. So that has come down, it's gone down 1. This one has gone up a half. So that would be a translation of 0, a half. So think about what the original cos graph looks like. So the original cos graph would start at 1. So it's going to start at 1.5. It is going to come down, and it's going to come down to just -0.5, and then it's going to come up, back up to 1.5. So that would be 3/2. That would be -0.5. There's the 360, 270, 180, and 90, y, and x. So this one has gone up a half. Translation of a half. Right, so this time we've got translations again. We've got pluses and minuses, but it's in the x direction. So this one is a translation of -45, 0. Remember, when it's the x, it's the opposite. So that tan graph is going this way, 45. So it wants between 0 and 360. So my asymptotes now, instead of being at 90 and 270, they're going to be at 45 and 225. So 45, 225. That's going to come down there, and it will go through 1. This is going to make the same shape, and this one will just make that bit of it. Theta, sorry, and y. So we've ended at 360, and it's cut through there at 315 and 135 rather than the values. So we're taking 45 off the 360 and taking 45 off the 180. This topic is where a graphical calculator will really come in handy, because you will be able to put them in there. So the next one is a translation of 90, 0. So we're doing it -360 to 360 this time. So we're thinking about this. This is going to move 90 degrees that way. So think of the cos graph and it'll move. And what it will do is it will look like this, which we should recognise as the sine graph. So when we move the cos graph 90 degrees in the positive direction, we end up with, sorry, that should go up to there. The sine graphs are minus 180, minus 360, minus 270, minus 90, 1, minus 1, theta and y. Right, so we have got y equals sine 2x. So this now is going to be a stretch in the x direction. And remember, it was the opposite, so of factor a half. So basically sine 2x is the sine graph that is going to repeat itself twice over the normal scale of 0 to 360. So normally between 0 and 360 there's one cycle. It's going to happen twice. So there's once, twice. My advice when you are drawing these is don't put the values on the axes first. Draw what you're trying to draw, sorry, that should be next, and then fit the values on. So what we will have here is that will be 90, that will be 180, that will be 270, and that will be 360. And it will be between 1 and minus 1. So think about what's going to happen. That's going to happen twice in one cycle. So draw that happening and then fit your values on. It's so much easier to do. Right, this one's the opposite then. So this is a stretch x direction, factor 3. So for that whole cos graph to happen, it will take 1080 degrees. So we're just doing between minus 540 and 540. So I know that it will only be half of the cos graph that will be happening. I got that by doing 360 times 3. So it will take that many degrees for a full cycle. We're only doing up to 540. So what we're going to get is that. That will be 540. That will be 270 minus 270 and minus 540. Still 1 and minus 1 because it's a stretch in the theta direction. Sorry, I should have said theta direction. Sometimes they use x's, sometimes they use thetas. So think about where the whole thing will be and then go from there and decide what we need. And the last one, y equals tan minus x. So that is a reflection in the y-axis. So we are doing a reflection in the y-axis. So we'll need asymptotes still at 90 and 270. We'll have that bit there. That will go that way round. That will go that way. Go that way, and there will be a bit there. So that will be the 360. That will cut at 180, cut at minus 180, minus 360 will be the end. Y and X. One thing I will say about these is don't worry about them too much. On an exam, if they ask you to draw one type of graph or two types of graphs, that is all that you will need to draw. Understanding what the actual transformation is the most important bit. Y equals sine 2x will get used quite a lot, so it is worth thinking about that. But don't worry too much about these. And I would suggest that if you haven't got a graphical calculator, which most of you don't, and we're not in school to use the school ones, use Desmos. Use that to be able to draw them and see what they are going to look like before you start. I hope that helps.